Hello, everybody. This is Mrs. Snook with section 7.7, the determinant of a square matrix. Now, a determinant is a real number, and every matrix has its own determinant. And so we are going to find the determinant of square matrices only. That means the number of rows and number of columns are exactly the same. And the determinant is useful for doing things like finding the inverse of a matrix. So first up, let's do the determinant of 2 by 2 matrices. And this is pretty simple and easy to do. First thing I want to do is show you notation. So sometimes you'll see it written like this, and that means determinant of matrix A. And other times, we just use these little bars. So if you see it DET, and then that is your matrix, or you can have the 2 bars and the matrix is there. So we're going to find the determinant of matrix A. So determinant of A is going to equal, and what we're going to do is we are going to multiply down this diagonal. So 2 times 2. And then we're going to subtract, and we're going to multiply up the other diagonals. That's 1 times -3. So I'm going to get a 4 plus 3 equals 7. And that's it. That's your determinant, just one number. Let's do the same thing for B. So your determinant of B is going to be 2 times 2. Minus 4 times 1. That gives me a 4 minus 4, or 0. Last one, determinant of C, is going to be 0 times 4 minus 2 times 1.5, and you'll get a -3. It's pretty simple. The next kind we're going to do is a 3 by 3. And that one involves a little bit of work. First thing you have to do is find what's called the minors and then the cofactors. In this example, we're just going to find the minors and the cofactors. We're not going to go all the way to the determinant. We'll do that in our next example. So the way you get your minors, and there's going to be a minor associated with each element in the matrix. So since I have a 3 by 3, that means I have 9 minors. And the notation we use for a minor is we put M, and then in subscripts, we're going to put which element this minor goes with. So if I'm doing the minor for the 0 here, I'm going to call that 1, 1. And the way this works is I'm going to cross out the column that the 0 is in, and then cross out the row. And then what's left right here, I'm going to pretend that's a matrix, and I'm going to get its determinant. So I'm going to do -1 times 1 minus 0 times 2. That gives me -1. So that's M11. Now, let's do this one. So we're going to do M21. So I block out the second row in the first column. And I'm going to do 2 times 1 minus 0 times 1. So 2 times 1 minus 0 times 1, and I get a 2. Now let's do the next one. Let's do M31. So block out first column, third row. 2 times 2 minus a -1 times 1. So 2 times 2 is 4, minus a -1 is 5. Okay, now I'm going to go and do my next column of minors. So right there. Second column, first row. So M12, 3 minus 8. M22. Block out second row, second column, 0 minus 4. M3, 2. Row 3, second column, it's going to be a 0 minus 3 equals negative 3. All right, let's get M1, 3. I'm going to do our last column, so just 3 more of these minors to do. Take away first row, third column. I get a 0 minus a negative 4. And that equals 4. M2, 3. Second row, third column. 0 minus 8 equals negative 8. And then M3, 3. Third row, third column. I get a 0 minus 6. Okay, now believe it or not, that was the hard part. Cofactors are super easy to do. Once you've done your minors, cofactors are a piece of cake. And the way you do your cofactors is you're going to take your minors and you're either going to change the sign or keep the sign the same. And there's a pattern that you use for your minors. And the pattern looks like this. I start in my first row, first column, I put a plus. That means keep the sign the same. Next to it is a minus, next to that is a plus. And I just alternate. Second row, I had a plus here, so I get a minus there, plus, minus. See how I'm just alternating? Third row, this was a minus, now it's a plus. That was a plus, now it's a minus, and then plus. So what I'm going to do is I'm going to keep the signs the same on M11, M31, M22, M13, and M33. So every spot on this matrix that's a plus, I keep the signs the same. Every spot where I have a negative, I change the sign. So I'm just going to write down my cofactors. I can do it by inspection, and there's no work I need to do because I've already done it. So C11 equals negative 1. Do not change the sign. C21, change sign. I had a 2, now it's a negative 2. C31, keep the sign the same, so I keep a 5. C12 equals, I have a negative here, so I'm going to change the sign. I had negative 5, so now it's a positive 5. C22, keep the sign the same, so I have negative 4. C32, change sign, was a negative 3, now it's a positive 3. C13, keep the sign the same, so that's 4. C23, change the sign, I had a negative 8, now this is going to be a positive 8. And C33, keep it the same. So negative 8 remains negative 8. And that is your minors and your cofactors. Now here's where this comes in handy. Our next example here, we have a matrix. We're going to find the determinant of this 3 by 3 matrix. And what you do is you choose either a row or a column, and you do the cofactors for that row or that column. So step 1 is going to be choose row or column. You only need one of them. And then 2, we're going to expand the cofactors. And here's what I mean by that. First, choose a row or column. My suggestion is pick one that's easy, 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 easy. And I see a 0 right here. So I'm going to pick something with that 0 there. And I think I'm just going to pick this first row. I have a 0, I have a 2, I have a 1. 0 is super easy. 1 is easy. 2 is kind of but it's all right. So I'm just going to pick that first one. I could pick any column I wanted. I could pick any row I wanted, but I've chosen the first one. So what I'm going to do is my determinant of A is going to equal we do A11 times C11. So that means my element in the array times the cofactor for that element. And I'm going to add it to A12, C12. That's this one, this element times its cofactor. And then A31, C31. And I only have to do it for that row that I chose. If I chose a column, I would do the same thing, but using the column. So now I'm going to go in here. A11, this is A11, that's 0. So I get a 0 there. C12. So now I need to figure out the cofactor. Sorry, C11. I said C12, I meant C11. So I'm going to find the cofactor of C11, of 1, So right here and here. I cross those out. I have a -1 minus 0 plus A12. So I'm going to take this element, A12, which is 2, and I'm going to get the cofactor for that spot. So I get 3 minus 8 plus A31, which is 1. So now I'm onto here. So I have a 1 times 3 times 0 is 0 minus a -4. It's a plus 4. So here's why the 0 was so helpful. That goes away. So you don't even have to get C11 if you don't want to, because you know it's going to go away because it's multiplied by 0. So determinant of matrix A is going to be 2 times a -5 plus 1 times 4. Well, I get a -10 plus 4, that equals -6. And that's my answer. That's all you have to do to get a determinant of a 3×3 matrix. And that's it for today's lesson. Thank you for watching and have a great day.